Hello, sixth graders. Today we are looking at solving two-step equations. The learning target we need to write down is I can solve two-step equations, either taking notes in your notebook or on the notes template.
Okay, so we want to think about what our ultimate goal in solving an equation is, which would be to figure out what the value of the variable would be to make both sides equal. So if we look at x minus 4 equals 6, we know, since we've been doing one-step subtraction equations, that we can go use the inverse and do 6 plus 4, and we know that x would be 10. 2x equals 12, 2 times something equals 12, and we know that x would be 6. Now we have a multi-step, so now we have more steps. So 3 times something minus 5 has to equal 13. So we need to think about, all right, going backwards and using our inverses to isolate the variable again so that we can figure out the value. So if we think of the steps for solving two-step equations, so cross this off if you're using the notes template and make that say two-step equations. They're very similar to one step. There's just one step that is a little bit different. So like before, we write the equation and then we draw our train tracks. Always, always, always do we draw our train tracks, especially with our two-step equations, because that's going to help us stay really organized. Then we need to isolate the variable. When we isolate the variable for two-step, we first use the inverse operation to remove the constant, so that's going to be addition or subtraction, and then we isolate the variable by doing the inverse operation to remove the coefficient, which is going to be multiplying or dividing. And we're going to do lots of practice problems to show you and have you practice how to use these steps. Then we solve for the variable, and then of course, one of the most important steps is to check your solution and make sure that it works in the equation.
All right, let's do this. So, solving equations, 2 steps. Solve 2 times the number plus 3 equals 9 and check your solution. So here I know that x was multiplied by 2, and then we added 3, and we ended up at 9. So to undo that, we are going to work backwards. SAD map is what Miss Little taught me. So I'm going to draw my train tracks. I know that left and right should be equal the whole time. If the last thing I did was add 3, I'm going to subtract 3 on both sides, keeping it balanced. So 3 minus 3 is just 0, so I'm left with 2x on the left, and I'm left with 6 on the right. You had 6 after you multiplied by 2, so let's undo that, and let's divide by 2. So I divide by 2, 2 divided by 2 is 1, I'm left with 1x, so 6 divided by 2 is 3. This means that I think x was 3 before it was operated on. So let's try it, let's check our solution, plug it back in. If 2 times 3 plus 3 equals 9, then I'm correct. Now we do forward order of operations, PEMDAS. 2 times 3 is 6, plus that 3 should be 9. A lot of you stop here, don't. Get to the reflexive property and actually check. 6 plus 3 is 9. 9 does equal 9. I'm a champion, my answer's right. And it's okay if you get the wrong answer, then you know and you can go back and fix it. If you feel ready, go ahead and try these. Otherwise, follow for one and then try. We have 2 times the number plus 4 equals 10. Let's find out what x was before we did all those things. Let's undo that adding 4 by subtracting 4 on both sides. That goes to 0. We have 2 times the number was 6. Hey, that's like the one before. So then I'm going to undo that multiplying by 2 and divide by 2 on both sides. So I get a single x is equal to 3, but of course I should check it. 2 times that 3 plus 4 should equal 10. 2 times 3 is 6, plus 4 should equal 10. 6 plus 4 is 10. Yeehaw, x is 3. Don't worry, x isn't always 3. So now 3 times the number plus 1 gives me 7. Okay, well, what was it before we did those things? Let's take that 1 back, subtracting 1. So we have 3 times the number was 6. Well, 3 times what number is 6? So we undo by dividing. X is equal to 2. Let's check it. Actually, let me say I messed up. What if I had said that was 3? If you plug 3 back in, 3 times 3 equals 6. Wait, 9 doesn't equal 6. That's how you know you are incorrect. So Luckily, I knew it was 2, so let's prove it. Math lawyers, proving it. 3 times 2 equals 6. 6 does equal 6. Woohoo! All right, one more, and this one might throw you for a loop, but you've got it. We're going to draw our train tracks. We are dividing a number by 3 and then taking away 5, and we end up with 2. So let's undo that in reverse order. Sad map. And so we are going to undo subtracting 5. We are going to add 5 to both sides. When I do that, we have opposites, and they cancel to 0. So what number divided by 3? Then I was at 7. So this doesn't mean I'm going to divide by 3. The number was divided by 3, so I'm going to undo that by multiplying by 3. And this is kind of like 3 over 1, right? So 3 over 3 is 1. So I'm left with m, 1m is equal to 21. Let's check it. So let's plug it in. 21 divided by 3 minus 5 equals 2. A lot of you are plugging it into not the original to make it work for you. Don't do that. 7 minus 5 equals 2. 2 equals 2. 21 is correct.
Okay, so we're going to keep practicing solving these two-step equations. So pause here, practice it on your own before you watch me go through them. Okay. So our first problem, 3x plus 2 equals 23. So we're going to solve for x, and then we're going to check our solution. Now remember, we are doing it backwards of order of operations. So I'm going to start with my train tracks. And I have to isolate the variable, get x all by itself. So the first thing I need to do is get rid of that plus 2 by doing the inverse. So I'm going to subtract 2 from both sides. I am left with just 3x on this side. Now 23 minus 2 is 21. To get rid of that 3 times the variable, we're going to do the inverse of multiplication, which is division. So I'm going to divide both sides by 3. These would cancel, and I'm left with x equals 21 divided by 3 is 7. I always have to remember to check my solution. So I'm going to plug that back into the equation in place of x. So 3 times 7 plus 2, does that actually equal 23? Don't just say it does, actually solve. So now we use order of operations. 3 times 7 is 21. Now 21 plus 2, that's 23, which does equal. So remember, this here is our answer, x equals 7, not the check that we did. Okay. Next one, again, you should have already tried this on your own before you watch me go through it. Okay. So our problem, 2 times y minus 7 equals 3. I have my train tracks going down the equal sign so that I can remember the two sides of the equation that we are solving on. So the first thing, I need to get rid of that minus 7. Do the inverse, which is to add 7 to both sides. These would cancel, and I'm left with 2y equals 3 plus 7 is 10. Now we have 2 times y, so we need to divide both sides by 2. And we are left with y equals 10 divided by 2 is 5. Plug that back into the equation to check. So 2 times 5 minus 7, we are seeing, does that actually equal 3? 2 times 5 is 10. Carry down the rest of the problem. 10 minus 7 is 3. So that does work. Our answer, y equals 5. And if you get the wrong answer in the check here, if you find that the sides don't equal, that means you need to go back and check the work that you did for solving the equation.
All right, we'll continue on doing some practice with two-step equations. So if we have 4 plus 5r equals 14, we can first rewrite it if we want to have our coefficient with the variable first. So we could rewrite it as 5r plus 4 equals 14, just because then we're used to having it set up like we've had it set up before. And then we follow all the steps that we've talked about already, train tracks, and then I can see that 4 is being added to 5r, so we need to do the opposite, and we're going backwards in our steps. So we're going to subtract 4 on both sides, keep it nice and neat and organized. That cancels out, leaves me with 5r equals 10, and then r is being multiplied times 5, so I do the opposite of multiplying 5, which is dividing by 5, and that leaves me with r equals 2. And then I need to put it back into my equation just to make sure that it works. So I'm going to check right next to this over here. 5 times 2 plus 4 equals 14. Does it really indeed equal 14? 5 times 2 is 10 plus 4 equals 14. 10 plus 4 is 14. So that checks out. So I go back, I circle it so it's nice and visible to see where my solution is. So R equals 2. If you would like to pause and try these three on your own, otherwise you can solve them with me or watch one more and pause, whatever you feel comfortable with to keep getting more practice. So 4x plus 5 equals 13. We do our train tracks. 5 is being added to 4x, so I do the opposite, minus 5. So I'm left with 4x equals 8, because remember 5 minus 5 is 0. 4x plus 0 is just 4x. 4x equals 8, so we do the opposite of multiplying times 4. We divide by 4. That cancels out. We have x equals 2. And then I'm going to put that back in. I'm going to actually show in my steps that I am checking it. So I'm going to rewrite it out using PEMDAS. 4 times 2 plus 5 equals 13. 4 times 2 is 8 plus 5 is 13. 13 equals 13. Sorry, I'm going out of order here because I ran out of room. That checks, so I go back, circle my solution. Remember, this is my solution because this is telling me the value of the variable that works to make this equation true. Not to be confused with this stuff down here. This is our check. This is our solution. All right, we have 8y plus 15 equals 71. Here's my train tracks. Subtract 15 on both sides. I get 8y equals 56. Divide both sides by 8. Y equals 7. And then let's pop that back in. 8 times 7 plus 15 equals 71. 8 times 7 is 56. Plus 15 is 71, which equals 71. It checks. Here's my solution. And then lastly, we have a fun one with fractions. So let's remind ourselves how to solve a equation with fractions. We have 1/5 x minus 3 equals 17. So there's a value being multiplied by 1/5, then subtracting 3, then we're getting 17. So here's my train tracks. It's 3 is being subtracted from 1/5 x. So we do the opposite and we add 3. So I'm left with 1/5 x equals 20. X is being multiplied times 1/5. Remember that we multiply by the reciprocal. The reciprocal of 1/5 is 5/1. So I do that over here, times 5/1. Remember I put a 1 under my whole number. So that 5/1 times 1/5 is just 1. I have x equals, multiply my top and my bottom. 20 times 5 is 100. 1 times 1 is 1. So I'm just going to leave it like that. And then I can check. 1/5 times 100 minus 3 equals 17. Well, 1/5, if I divide 100 by 5, I get 20. So 1/5 of 100 is 20. Minus 3 would be 17. 20 minus 3 is 17. So that checks out. So I know then that x would be 100.
Okay, team, you've made it. Now is your chance to show us what you know and post it to ClassKick. Don't forget to do that. It's hard to help you if you don't show us what you know. Remember, the solving two-step equation steps are really just undoing in backwards order. So instead of PEMDAS, that's what you do to check it, you're going to do SADMAP. You're going to work backwards, okay? You're going to undo. You can do this. Show all your thinking. Remember, the expectation in 6th grade is that you show us your understanding of inverse operations. You can do it. Go you.